Next, we are going to see about speed control of three-phase induction motor. The three-phase induction motor is practically constant speed motor like a DC shunt motor. But the speed of DC shunt motor can be varied smoothly just using simple rheostat. But in this case, the three-phase induction motor is very difficult to achieve smooth speed control. So that this speed of induction motor can be controlled by basically two methods from stator side control and rotor side control. From stator side control, supply frequency control, supply voltage control, controlling of number of stator poles and adding rheostat in the stator circuits. Then from rotor side includes adding external resistance in the rotor circuit, cascader control, injecting slip frequency. So we know that the synchronous speed ns is equal to 120 f by p. So here v by f control is nothing but v by f control. So synchronous speed ns is equal to 120 f by p. So the normal supply voltage available constant frequency is supply. The converter converts the supply into the DC supply. DC supply. So this DC voltage is given to the inverter. The inverter is a device which converts DC supply into the variable frequency AC supply is required for the. Then one second. The next one is adding rheostat in the stator circuits. We have seen that reduced voltage can be applied by stator by adding a rheostat in the stator circuits. So the part of voltage gets dropped across the resistance and reduced voltage gets applied. This is the stator resistance control or primary resistance control. Here the variable resistance can be added in the stator side. This resistance will reduce the stator voltage in the windings. So the reduction of stator voltage causes reduction in the speed. The rheostat can be varied as per the required change in speed, but the entire line current flows to the rheostat. But the entire line current flows through the rheostat, hence there is a large power loss. The method is efficient from speed control point of view, hence I used the starter rather than the speed control method. Then the cascader control, this is a diagram for the cascader control. This method is also called as tandem operation of induction motor. In this method, two induction motors are mounted on the same shaft. One of the two motors must be slip ring type, which is called main motor. The second motor is called auxiliary motor. The stator of main motor is connected to the three-phase supply, while the supply of auxiliary motor is derived at the slip frequency from slip rings from main motor. This is called cascading motor. If the torque produced by both act in the same direction, cascading is called cumulative cascading. So PA is therefore NSB is equal to 120 F by P, that is equal to 120 NSA minus NF by PB into S. Then there's an injection of slip frequency in the rotor circuits. This is a diagram for the there are two methods used in the Grammar method and Serbius method. This is a diagram for the Grammar method. It consists of main induction motor M, the speed of which to be controlled. The two additional equipments are DC motor rotary converter. The DC side rotary converter feeds the DC shunt commutator, which is directly connected to the shaft of main motor. A separate DC supply is required to excite the field winding of DC motor, the exciting winding of rotary converter. The variable resistance introduces the field circuit of DC motor in the field regulator. Okay, thank you.